Hi, everyone. Welcome to this episode of Security Blueprints, where we're going to be looking at the security architect's view of Redis. Now, Security Blueprints is a dedicated channel where we'll be talking security architecture and security engineering and everything in between. So, I look forward to starting this new blueprint session on Redis, which is a very important area for a lot of different applications that are delivered with Redis as the backend or the cache in many ways. So let's get started with Redis security architecture. So in this video, we're going to be approaching the security architecture aspects of Redis and what you could do when it comes to Redis security architecture and how you should be thinking about securing Redis infrastructure. Now, first of all, what is Redis? Redis is a key value store, which is one of the most popular key value stores out there. And it would be typically under the category or the broad categorization of a NoSQL database. You can store keys and you can store values, and you should be able to look them up very quickly. The reason Redis is so popular is because Redis is very fast and it can be used in a variety of different use cases. So Redis can be used as a primary or secondary key value store. It can be used as a cache. It can be used as a backend for other databases. So there are some databases that I know which use Redis under the hood and they have their additional database logic sitting on top of it. Redis is used as a session store for caching and for multiple applications that are load balanced. Redis is used as a way to store values temporarily, or even not just as a cache, but even slightly more complicated use cases in terms of you being able to manage other key value store kind of use cases. This is a very important aspect of Redis, and this is why Redis has become so popular. Redis offers, of course, self-hosted options, and you, of course, have the ability to use their cloud, or you can use Redis in different cloud providers. Each cloud provider, I'm sure, has their own version of Redis. They may not call it Redis, but they use Redis, I'm sure, under the hood in some way, shape, or form. Redis had a few issues in terms of licensing. They used to be an open source license, then they became a closed source product, then they again went back to being open source. So you see that it's gone through a lot of changes over time. Now it's back to being open source, and they do support their open source quite extensively. They also, of course, have their own Redis cloud, and they have managed Redis services across different environments like AWS, Google, or Oracle, or Azure, right? So let's talk a little bit about Redis, and I've also prepped a little bit of a small presentation to help you understand some of this stuff. The thing that I think has made Redis popular is that it works really well in memory, which means that that's why it's fast in terms of looking up. It does eventually write the data to disk, but it works really well as an in-memory store, which is why the caching use case is perfect for Redis. And you can set up clusters and you can do high availability and so on and so forth. Redis IO has a pretty decent security page, but I think there are a lot more things you can do in terms of this to think about. Now, the biggest risk with Redis is that you store sensitive data on Redis and somebody can potentially get access to it. I would say the even bigger risk with Redis is the lack of availability issue that you'll see. So let's say a cache is gone, or your Redis key value store that you are handling, let's say subscription data or something like that, is gone, then it becomes a big issue. So Redis, I think the availability aspect becomes a very important thing, and the access to data, which is typical of most databases, is also a very important thing when it comes to Redis. So let's quickly look at the Redis security architecture. Typically, Redis has databases. You can select multiple databases 0, 1, 2, 3, 4, so on and so forth. This does not offer any isolation in the sense that you just have databases. They're not really isolated from each other. If you really want strong isolation with Redis, you want to separate things out. And this might be a good idea in multiple ways, simply because in some cases or for some applications, you may be using Redis as a cache. And for some, you'll be using it as a persistent store. So it might be useful for you to run them on completely separate instances or completely separate clusters. Do not use Redis like you would use an RDBMS. In RDBMS, you could typically have multiple databases and you could have strong separation between them. But in Redis, I recommend you use different instances simply because the way you would configure Redis in terms of in-memory versus persistence and the speed of persistence and the kind of commands that you want to run and the kind of code that you need to use is going to be very different. So that is why I would suggest using single tenant isolation. Redis by default comes with private network only, which means that it's not meant to be opened up to public networks or over the internet, which is what they say in their document as well, binding it to the local host, which means that somebody from outside will not be able to access this. Redis, at one point in time, if I'm not mistaken, used to have a model where they did not have any authentication, or they had some basic authentication and absolutely no authorization or something like that. They did address that, and I think there are third party solutions to address that as well. But that was really what Redis was created for. It was created as a very, very quick reference key value store, and they didn't really so much care about the isolation or the authentication. More than authentication, I don't think they cared much about the access control of things, right? So that is something that you have with Redis. So definitely private network only. They do have MTLS and support passwords and so on. Of course, MTLS would be better than using passwords. It really depends on whether you can and whether you want to in terms of your ability to or your risk factors. Redis also has ACLs. Now, ACLs allows you to set up access control lists. While I wouldn't say it's new, it's definitely not the most common thing that you see in Redis deployments. I see Redis deployments all the time where none of this is used. None of this is deployed. It's not one of those things that is natural to Redis, or it's a natural configuration set of parameters that people do to Redis, right? So in terms of, yeah, you'll see that there are, like I said, there are different types of Redis deployments, right? You might see cache only where they don't append, which means that they don't save stuff at all. So there is data loss here because it's just cache, but again, it doesn't really matter because it's a cache, there'll be data loss, but then hey, the cache will build up again. So that's how it happens in a lot of Redis instances. But when you're dealing with Redis that is saving or persistent data on the disk, then obviously you need to have the save parameters and you need to think about it a little differently. So the way you use Redis impacts the security architecture of how you should think about it quite extensively. Now let's talk a little bit about Redis configuration and access control, or IAM, on Redis, right? So the first thing you should think about with Redis is obviously enabling access control and enabling something called protected mode. Now, protected mode in many cases is not turned on by default. Many users will fail to protect Redis instances, so just be left exposed. Since version 3.2, Redis enters a special mode called protected mode, where when it's executed with the default configuration, binding on all the interface, without any password to access it, only replies on queries and clients connecting from other addresses with an error that explains the problem and how to configure Redis properly. So this is version 3.2, but obviously this is not going to be a lot of Redis instances. If you see here, I just did a basic search on Shodan and you see a whole bunch of IP addresses with no authentication configured for Redis and some automatically showing compromised and so on and so forth. So you will see that this is happening and this is very common with Redis, especially internally. I would see that the biggest risk with Redis is going to be internal configuration where there is no authentication enabled, simply because people don't assume that people will be able to access it. Obviously, recommend using TLS on Redis because, like everything else, you should have TLS. Now, in terms of Redis, one of the things you can do is set up an ACL. So this is really how you can set up ACLs, right? So have the default user set to off, ensure that you set up ACLs where you say that user with this password on application A. So you can, one of the things you can do with Redis is you can do namespace keys per application. You can do based on the kind of applications you want to use, you can do key prefixes. So let's say your key starts with app A. You can always do that. Okay, based on these prefix, you can do read write and do not allow dangerous eval script. So they have certain types of things called dangerous eval script, certain permissions that are potentially dangerous, where you can write scripts, you can do eval queries on top of it, and whatever dangerous is. I need to figure out what that is, but dangerous, I'm guessing, is a bunch of all of these different parameters. So let's see dangerous in Redis. What does that mean? ACL. Okay. Potentially dangerous. Dangerous. Okay. Dangerous. Potentially dangerous commands. Flush all, migrate, resort. Okay. Key, client, debug, config, save, replica. These are potentially dangerous things. So this is definitely something you want to look at in terms of the command categories and their meanings, and only allow things that you actually want to allow, right? So this is something you want to do. The other nice thing that you have with, so the ACL stuff you have to create and obviously use this with the namespace for whatever namespace you want to do. You can also start to completely disable certain commands like flush all, flush db, config keys, and all of that stuff, which means that nobody will be even able to access entirely with what you have. You can set up memory limitations on this kind of size that you have and so on, in terms of the key size or the value size and so on that you have, and you can do all of those things. This is something that you should definitely be looking into, because Redis, this is where Redis tends to get compromised the most when it comes to authentication, and more than authentication, authorization with ACLs, right? You can obviously block some dangerous functionality, look at what they consider dangerous functionality along with other things that you might want to restrict, and allow them only specific things that you want to allow them for to use. The other aspect of Redis that I want to talk about is, of course, logging. Now, you can log certain things, which is specifically authentication violations. This is a very good thing to do. So you can log this. And if you see a lot of scan or config parameters, config queries, and so on, this might indicate that somebody is trying to enumerate and attack, combination of all of this stuff. So things like this, right? Search and scan keys, get all type of queries means that somebody is potentially enumerating it, because most applications will just be selecting specific keys and coming back with specific responses. One of the things that I've seen that you should probably avoid is the lookup of keys in your application. So this again depends on the data access patterns that you have. Your application should ideally have a key value lookup rather than you searching for keys all the time. So that might also create anomalies. So you need to think about how you do data access. So that would be something that you should definitely look at with the kind of things that you can do with Redis. Now, Redis by default does not offer any sort of encryption. You have to encrypt the disk if you want to encrypt Redis. You might want to handle encryption in your application and then push that encrypted payload to Redis. Do not expect Redis to transparently or do that in terms of what you think it can do for you. It's not going to really work, right? So that is something that you might want to do. So that is encryption. That's another thing that you have to do. Definitely consider looking at doing that from an encryption perspective if you want to encrypt things. Otherwise, you'll have to encrypt things in your application and then send them out to the Redis instance itself. So there are certain commands that you should stay away from, which is obviously some of this, all of this stuff which I'm talking about here. I used to assume that the eval command, it used to be the thing that used to cause a lot of issues, where you used to have eval and because of that there would be remote code execution or something like that. Apparently now that's not so much of an issue, because eval and eval sharp follow the same rules. So apparently they execute Lua scripts in the background, and apparently they are not as dangerous anymore. I'm not sure whether they were always this way, but I think there's probably been some changes, because I mean, of course, the security community hates eval, and that is something we frown upon. But apparently, based on their own documentation, they said those commands are also safe, because I think they might have reduced the type of execution scope that eval has. So maybe that's the reason why it's not so bad anymore. Let's look at the next one, which is high risk operations. So these are what I would call high risk operations. So data destruction, obviously flush all, flush DB. This would be the biggest things, especially when you're dealing with caches and so on. This could cause a real disruption to your application. Config set. In fact, I remember doing a class in which I was able to simulate a creation of a Redis replica, and I was able to, replica of slave off. I used to be able to use this and then exfiltrate data from a Redis database to my own replica, right? This was a very interesting attack that I was able to do in a real pen test, and I also loaded this as a lab in one of my classes. I remember this was a very interesting attack set. So obviously you can reduce this by removing those commands itself. That's something that you can do. This seems bad, although the eval part of it, I'm not really sure. But in terms of the other stuff, Redis script command, I'm not sure what the script command does. Seems like it's all been, based on the Lua logic or the Lua interpreter, Lua scripts that run inside of it. So maybe there are certain parameters that they've addressed, which does not seem to be so much of a thing that I see nowadays. Right? I don't see this being a huge security risk, although I'm not sure based on the version that you're dealing with. So you may not have as many issues with this with the newer versions. And they've clearly said that these seem to be okay by and large. But maybe something that you still want to avoid, especially if you're not using it, there may be something that you want to avoid using. Data harvesting obviously is going to be the biggest use case. I would say these two, data destruction and data harvesting, would be the biggest things that I would use a Redis database for. So that would be my biggest focus here as far as I would say. So in terms of security architecture, I would say block operational controls, use certain types of operational controls for Lua, for your Redis when you're running this. Memory, obviously, you can set up memory and memory policies and so on. You can have a TTL. So TTL is always good when you're using a database because it means that once that time is expired, that entry gets removed from the database. And it's always a good thing to have that situation there, especially when you're dealing with a cache Redis. So, of course, all of this stuff would make a lot of sense. This is more OS hardening, really. Run as a non-root user, drop capnet admin, because if this potentially leverages remote code execution, then they might have that sort of a situation coming in. Resource isolation in terms of if you're using Kubernetes namespaces and so on. Yeah, this is something I think we've already spoken of a little bit, and still something that you might want to look at is do not expect database to be isolation of any sort. So you might want to segment it out. And of course, if you're using Redis images, Redis instances, Redis code bases, whatever, you need to ensure that you have an SBOM and use that for this, right? So this is another thing that you can use on top of Redis, which is allow list, where you can have IP address allow lists only, which is probably a good thing to do. And sign and verify artifacts, which is again Redis binaries that you're using. Make sure that you sign them so that you can use those Redis binaries specifically for your application or code base. So this is stuff that we've discussed actually. If you see all of this stuff that we can do with Redis, I would say that the biggest issues that you'll see with Redis is going to be availability loss, because Redis is meant to be a highly available system. And in terms of you being able to compromise the application and bypass or get information disclosure. So definitely think about those aspects when you're dealing with Redis and focus on that and orient your configuration parameters towards that sort of thing, right? That's something that you should definitely be doing when you're dealing with Redis. All right. Thank you so much for watching this video. I hope this was useful. And if you are interested in this and similar content, I would recommend you like this video and subscribe to our channel Security Blueprints, where we will be putting out more content on security architecture, security engineering, and everything in between. Thank you so much. Have a good day.